So we're doing um, okay. Dania, are you there?
Sir, me?
Yeah.
Yes.
Dania, can you leave the meeting right now and join like exactly 30 seconds later? Some maybe your device is interfering with the software. Okay.
Okay.
Never mind. So we're gonna look at this. First question says the solid metal has the diameter of this, and the mass is this. Okay. And then is calculate the density of the metal in grams per centimeter cube. So we have luckily grams and centimeter. Density is mass over volume. Sorry, I'm a bit sick. So this is going to be 67 divided by 3.42. And then what you're going to do is you're going to just divide this. Wait a second, please. 67 divided by 3.42. And that's going to be 19.59. So because this wasn't too significant, it was a 3, so you take minimum significant figures as 2 or maximum as 3. You can't go beyond that. So we're going to write it as 19.6 grams per centimeter cube. Anyway, then says determine
Sir,
the. Yes.
we're using the diameter instead of the
Sorry?
3.42 is the diameter.
Oh, oh, it's the diameter. My bad. Sorry.
3.42.
Yeah, I just realized this. So we're going to find the volume. This squares 4 by 3 pi r cube. So we're going to write 4 by 3 by r cube. I'm going to put the formula in the correct order. 3m over 4 by r cube. Because 3 will go top multiply again. Okay, so then this is going to be 67 divided by 4 pi, and that's 3. And r will be, because 4 pi r, this is radius. Oh my goodness, wait. We have to further change it. I'll tell you why I'm doing this in a better time. So volume of a cylinder sphere is 4 by 3 pi r cube, and diameter is radius, like 2 times diameter half is radius, so we're going to put it here. So this is diameter by 2 cube, and now I'm going to get 4 by 3 pi d cube, and 2 cube is 8. So 4 1 4 2. So we're going to get 1 over 6 pi d cube as the volume of sphere in terms of diameter. Now density is mass over volume. I'm going to write mass 1 by 6 pi d cube. And 6 will go on top, so this will be 6 times mass over 6 times mass over pi d cube. Now I can simply find this. This is going to be 6 times 67 divided by pi, and the diameter was 3.42 whole square whole cube. Okay, so I'm gonna use my calculator now. 6 into 6.67, sorry, 67 divided by shift pi times 3.42 cube. So I'm getting the density as 3.20. Okay, now what you're going to do is, it says determine the percentage uncertainty. Okay, so when you're doing this, because you have diameter and you have mass, the best thing is that you're going to use this formula. Okay, so I'm going to use the diameter density over uncertainty density, or density equals to uncertainty in m over m plus uncertainty in d over d. Now because there's 3 here, so I'm going to multiply 3 here. And now just simply add the values, like mass was 2 over 67 and 3. This was 0.02 over 3.42. Now by finding this formula in the first part, I've actually made my life easier, by then I can find the uncertainty easily, right? So then I'm going to get the fraction of it, and that's going to be 2 divided by 67 plus 3 times 0.02 divided by 3.42. So the total is 0.04739, and to find like percentage, I got to multiply this by 100%. Okay, so when I do that, it's going to be 0.4.7%. So that's 4.7%. That's what you got to write. Please check your answers. Let me know if there's a question you have. Anyway, so going to the next then. This question, I don't know, I've never seen this before. So, so in this question, it says that arrow hits the center of the target, and it is shown that the time taken for arrow reach the target this. So we got like an angle of 4.3. We got a horizontal distance. This is a projectile question. And the arrow is released with the speed of this. So first of all, we're going to make 2 components, one horizontal component and one vertical component. The horizontal component is going to be 65 cosine of 4.3, and the vertical component is going to be 65 sine of 4.3. So because we have horizontal component and we also have the horizontal distance, so we can simply use that, because in horizontal you need only 3 things: displacement, which is 70.0, velocity 65 cosine of 4.3, and time is what we need. So we're going to use velocity is equal to displacement over time. 70 divided by 65 cosine 4.3. And just check your calculators. They must be in degree mode, not the radian ones, especially after your math exam has finished. So I'm getting exactly 1.0799, which is equal to 1.08 seconds. So I have shown it like that. So if you have any questions, do let me know. Okay. All right. Finally, we are going to go towards this one. It says calculate the height of the
Sir,
center. Yes.
sir, I simply used 70 divided by 65 and I got the same thing.
You simply use 70 divided by 65, and
Yes.
that is the correct answer. That couldn't be correct answer, right?
I got 1.0769.
Okay, but I don't think they will mark it correct. You have to show it, right?
Okay, sir.
Okay. You have to take. Suhail, this is very disappointing, by the way. Okay, now, so then we're going to go to the next. In the next, we're going to see what exactly they are at. So it's saying calculate the height of the center of target above the ground. Height of center of the target above the ground. So this is the center of the target, and you got to find this height. Oh, interesting, huh? It's very, very interesting. So I'm saying if this is like where the height was, like when it was released, this is something interesting. How would we go about it? I don't exactly know about it, but let me see. So we're gonna use the vertical because we want the vertical height. We use something vertical to find this, and to do like they have this height already given to us, and if we find exactly where the arrow would basically hit the target, we can somehow do this. So I'm gonna write for vertical. You always write SUVAT. We want to find this obviously. The initial velocity is the vertical velocity, which is 65 sine of 4.3, and the final velocity I don't know. At the end, I don't know because I'm basically targeting it will go like this, and I'm targeting the velocity right here, the vertical velocity right here. So I don't know. So the acceleration, because it was going up, so I'm going to take it as negative 9.81 meters per second square. That's because it was going up. Okay, this was going up. And then the time that it took to reach this point was this, because time is always independent. So I'm going to write 1.08 seconds. Okay. Then what I'm going to do is I'm going to use S equals to ut plus half at squared, because that would be the easiest as I do not have final velocity. The initial velocity is 65 sine of 4.3. The time is 1.08 plus half minus 9.81, and then 1.08 whole squared. So let's try to do this. 65 sine 4.3 times 1.08 plus 0.5 times negative 9.81 times 1.08 whole square. So I'm getting something like negative 0.46 meters. Okay. It means from the position that I was standing on, that the person was standing on, the target has gone like below that. Okay. Now, if the total distance, like it has hit here, so it has gone from the top, it has gone somewhere like 0.46 meter down, right? And if the total distance from the target was 1.66, so to find like the total from here till here is 1.66, and I only want to find this much height, so I can subtract them. Okay, so then I'll do 1.66 minus 0.46, and that's going to be, I don't know,
1.2.
1.2. Okay. Yeah. So if you have any questions, please let me know. Anything you'd like to ask. Um, s- okay. Ayan, Aisha, Dania, Dua, Juwairia, Khadijas. The other Khadija is not here yet. Okay. Maham, Suhail, Umar, Hamad, everybody. Okay. So going to the next. Then says by considering energy changes, they explain how the finite kinetic energy arrow as it hits the target compares with initial kinetic energy immediately after release. Um, so if you notice that initially at this point when it was released, it had this much kinetic energy depending on the velocity, right? This much. And now obviously if it has gone like below the firing line, so this is your firing line, so below that, so it means that not only the gravitational potential energy has decreased because initially at it was at this height and now it is at this height when it hit. So gp decreases, and obviously if the gp decreases, it has fallen more than it should, so it means that its kinetic energy will be even more. Okay, so we're going to write number one, gravitational potential energy decreases, hence kinetic energy has increased, so speed will be higher. Now, please do not write it was lost to the surrounding, stuff like that, unless you're absolutely sure about it. Okay, please let me be very clear with you. Now, in A levels, they will test you with different kinds of questions. They're not going to give you O level questions like every time they ask about energy changes, you will say, oh, something was lost in the surrounding, and then blah blah blah. So that would be wrong. Please don't do that. Then the next question is velocity. You can basically get away by writing displacement over time. You can actually write this, and that's fine. No worries, okay? Then you have force and you have mass, and they say assume no resistive forces and acceleration. So acceleration is force per unit mass. So 2400 divided by 12, and that's going to be 2.0. Now, what happens if you write 2? It would be wrong because you do not have the correct number of significant figures. So you have to write 2.0. Do not write 2. Okay. Now, then it says sketch a graph variation velocity of the car and blah blah blah. Okay. So we have the acceleration, and we're gonna say what will be the velocity after 20 seconds because acceleration is change in velocity over time, right? And so acceleration was 2 from 0 till 50. It's 50. Oh, we want to find the final velocity. Initial was 0 and time was 20. So this is going to be 2 into 20, 40. So final velocity will be 40. We're going to go here, and then we're just going to make a straight line like that. Okay, so this would be our graph then. So then it says, in reality, resistive force due to A resistance on the car in B. This resistive force increases with speed until it becomes equal magnitude in driving force, and that would mean that yeah. So then it says label this line B. You have to draw this line with variation label. So what happens is that it will go like in a straight line. Initially, the acceleration will be the same, but the acceleration will start to decrease. Okay, and decreasing acceleration is shown by the decreasing gradient. So you will see a line like that. Now, okay, you must go straight and then zero, like flat line, flat gradient like this. Okay, so label this line B. That's what they said. Okay. And then on at time t0, the driving force will increase to this and remains constant at this point. Describe how the velocity of the car changes. So if you increase the driving force, then what will happen is that obviously there will be greater acceleration now. There will be acceleration. So velocity will increase. So does resistance till a point where um, driving force and resistive force become equal again, and car reaches terminal velocity. You can use the full space, not like me, like that. So you can always write this. So there will be a new higher terminal velocity again. Any questions, please let me know. So then, please correct your work as you're doing this. And then in question number 4, it says mass m moves a vertical distance delta h in a uniform gravitational field and gains gravitational potential energy, and use the concept to show. Fine. So it's pretty simple. If you move up, your weight is equal to mg. So to carry the weight, you have to do work against the height you're going up, right? So we're going to say force to do work against is mg, and the height raised is delta h. Okay. So that would mean work done, which is basically force times displacement. This is force mg, displacement is delta h, which is equivalent to change in gravitational potential energy. And that's it, what you got right. That's the derivation. And then says 60 kg mass is attached to a string which is wrapped around the wheel of generator as shown. And the mass is held stationary above the floor. When released, the mass initially accelerates and falls at steady speed and spins the wheel. The generator causes a current in the resistor. A resistance negligible. State the main energy changes. Um, Obviously, you're losing gravitational potential energy, so I'm going to write GPE here. In fact, you should write the whole thing. Gravitational potential. Gravitational potential energy to obviously the it's causing current. And remember whenever a generator causes current, okay, um, it would always go to thermal energy. So you can write thermal or heat if you want. Okay. Now, why won't you write electrical energy? The reason why, because electrical energy is not being stored in a battery or something. You're not charging batteries. What you're doing is you actually have a resistor here, and resistor will have a current, and when the current passes through the resistor, it is going to dissipate the energy into heat. So unless you're putting something into a battery or a capacitor or something, you do not write electrical energy. You guys get my point? So this is the initial and this is the final form. So that it could be intermediary energy, but not the final one. Get it? Dua, Dania, Javeria, Aisha, Mayan, Aman, Khatija Mam, Ryan Swift. Okay, Hamad, Umar. Everybody understands this? Please let me know if you don't. Finally, it says when falling at steady speed, the mass in V falls to a vertical distance of this in a time of 4. This causes a current of this, and the resistance resistor this. Calculate the rate of work done by the falling mass. Oh, okay. So work done. Oh, interesting. So we do not have like, yeah, you have to do the rate of work done, which is the power. You got to find the power. So we can do force time velocity. So
Here we can do mg delta h over the time.
mg over h, yeah, we can do that too. You're right. Do we have the mass?
We have it
Where? Where did he get the mass?
0.6. It's
Where
in the diagram. In the diagram.
in the diagram? Oh, yes, yes, yes. Good. So 0.60 times 9.81, that would be the mg, and the height it has fallen is 1.4, and the time is 4.0. What you get then? You guys haven't done this?
Sir, we get 2.1.
2.1? Okay. So you got 2.1 watts. And then the power dissipated in the resistor. So you have the, oh, you have current and you have resistance. So you can use power equals to I square R. 19 to 10 is to minus 3 whole square, and R will be 47. That's going to be
0.38.
0.38. Okay. And then efficiency, because this is the power dissipate, that is the work done by power. So this has to be the input and that has to be the output. So this divided by 2.1, right? So multiply, and you don't need percentage. So just directly do that. 0.38 divided by 2.1, and that's going to
18
be
percentage it would be.
0.18. Yeah, 0.18. That's fine. You can write 18% as well. Okay, fine. Then blank page. Okay, so this one. So in this one, it says the radius is 5.5. The intensity of the sun in magnifying glass is this. Assume all the light incident on the magnifying glass is transmitted through it. Calculate the power. So intensity is basically power over area, if you don't know, and that's basically 5.5 is the radius. So area would be, if it's circular, pi r square, right? Okay. So then let's do this. Power will be, intensity is 1.3 times 10 raised to the 3 because there's a kilo here, multiplied by r square, pi times 5.5 times 10 raised to minus 2 because I need to change it to meters, and then whole square. Okay. Okay. So I'm getting something like 12.35. So I'm going to write it as 12.4. Okay. Watts. But you can write 12 as well. But then, because it's also characteristic. Then the value of R is 1.5 mm. Calculate the intensity of light on area A. So value of R. Eh? Oh, this R. And interesting, huh? It's very, very interesting. So what to do now? So you have the same power. So you can use intensity as power over area. We want to find the intensity. So power will remain the same. The area now decreases. So pi, and this is 1.5 times 10 raised to minus 3 now because this would be changed to meters square. Okay. I don't know what that is. 12 shift pi times 1.5 times 10 raised to power minus 3 and whole square. So I'm getting something like 1. 1.69, 1.7 times 10 raised to power 1, 2, 3, 4, 5, 6, 6 watt per meter. Okay. Please check your answer. Let me know if you need me to explain this to you. Okay. Now, a laser emits a beam of electromagnetic waves. Show that the wavelength of this is. So V is equal to F lambda. You guys need to remember that for electromagnetic waves, the speed is 3.0 times 10 raised to 8. You need to remember this. So the frequency is 3.7 times 10 raised to 15, and we want to find the lambda. And I believe if we divide this, this will give us the right answer. I don't know. Let's try it. 3.7 times 10 raised to power 15. Yeah, it is sort of giving me 8.1 times 10 raised to minus 8. Okay, perfect. So shown, and then says the region of electromagnetic with these. So now you guys need to understand this very, very important thing. If you ever get stuck in this question, just remember that visible light is exactly at 10 raised to 7. Okay. And the real range is from 4 to 7. Okay. Like what I mean by this is like 4 into 10 raised to 7 to 7 into 10 raised to 7. So this is the real range. Beyond this, if it's closed like 10 raised to 8, I would choose ultraviolet, right? If this was like 10 raised to 6, I would have chosen infrared. Anything below this, like 10 raised to power, like this is, sorry, minus 7, I would say, no? Like for example, 10 raised to power something like 3 to, so I'd use microwave. And if it's positive number like 1, 2, 3, then radio wave. And then above this is like 10 raised to 10 is around X-rays, and 10 raised to 12 and beyond is like gamma. So if you remember this, you can actually guess what kind of wave this would be. So just remember that. Now, the moment I see this, I know this question belongs to d sine theta equals to n lambda. Okay. And the other formula is to find d, it is 1 upon n. So we're going to see what it is about now. So the beam of the laser now passes through diffraction grating of this lines per millimeter. So this is n, and the detector sensitive waves emitted laser move through an arc of, okay, so the detector moved through 180 degrees, starting from here, obviously. And it's in order to detect the maximum produced by waves passing through grating. So, fine. So it says calculate the number of maxima detected at the detector move 180 along. So basically, he's talking about all the orders. If you're talking about all the orders, it means then sine theta should be taken as sine 90. That's it. So we're going to use this. First of all, we know it is 2400. It is basically 2400 lines per millimeter. So n is per millimeter, n. So I'm going to find d first. So 1 upon 2400, and that's going to give me something like, interesting, 4.167, okay, millimeters into 10 raised to minus 4 as well. So if I want to change it to meters, then so I have to multiply by 10 raised to 3 minus 3. So 4.167 times 10 raised to 7 would be meters. Okay, so we've done that. Now you use d sine theta equals to n lambda. D is 4.167 times 10 raised to minus 7. You have to take theta is 90. We got to find n, and the lambda of these, I don't know where it was. I think this is the lambda, right? 8.1 times 10 raised to power negative 8. So I'm gonna use my calculator. By the way, if you don't know, sine 90 is just 1, so you don't have to worry about anything. You can simply divide 4.167 times 10 raised to power minus 7, and then divide it by 8.1 divided by 10 raised to power minus 8. So that's going to be 5.14, and you always have to round it. So this will be, n will be 5. You can, if even if the answer was like 5.99, you would still take 5. So it means basically you will have 1, 2, 3, 4, 5 on one side, 1, 2, 3, 4, 5 on one side, and then one the central one. So total will be 5 plus 5, 10, and 11. Is it clear, everyone? Any questions? Let me know. Okay. So just to remind you people, because we have it's 2n plus 1 that I've used for all orders. If they say excluding central, then you use 2n, and only on one side, then you use n. That's it. Okay, so the laser is now replaced with one that emits electromagnetic wave of this. Without calculation, it happens the number of maxima. So the first thing that you guys need to understand is that if the wavelength increases, then the diffraction also increases. And if the diffraction increases, okay, so that means that n would be less. And you can also compare this by, the formula is d sine theta equals to n lambda, so they'll pass through the same slit. If I divide lambda down, so d sine theta over lambda is n. So n and lambda are like inversely proportional. So the greater the lambda is, the less the number of orders are going to form. So we're going to say wavelength increases. So the number of orders, number of maximas formed will be less. Is it clear? So just remember that. Any questions, please let me know. Finally, we're going to go to 6. How many questions do we have? 7 or 2 questions? So for filament lamp, it's basically like this. It's a fact question. You got to remember this. Then it says explain the shape of the line, and why the shape of the line is like this, because number 1, please write for 3 marks. Current increases as potential difference increases. Current causes heating. Okay. Temperature increases. Number 3, temperature increases. So resistance increases. Hence, ratio, because R is equal to V over I, resistance increases, current decreases. I mean, the ratio of V, if the resistance increases, then this ratio will be smaller. So V over I increases. That's it. Like that. So you can remember that and just write this 3 points. This will always be the same thing. Then it says conducting wire has a length of 5.8, cross-section wire resistivity. So R is equal to rho L upon N. You got to find the resistance. I don't think so. They're gonna give you like this is so easy. 5.6 times 10 raised to minus 8 times length is 5.8 and cross-section area is this. Okay, this is like O-level question. Not even diameter is given. 5.6.
9.6.
Sorry?
9.6.
9.6. Okay, thank you. 9.6. And now this question. So it says a resistor of resistance R in the circuit with a cell internal resistance, blah, blah, blah. And it says the switch open and open. If you keep both the switches open, then the current is 0, fine. And then if you open one switch, which is S1 is open and S2 is closed, then obviously this will be like a circuit with 2R resistance. Okay, that means Z and A will both be in like series, so they're showing you the same current. So I don't know the current. The reading on X is 1A when S1 is open and S2 is closed. Oh, okay, fine. So then on Z it will be the same, like 1.0. And Y it will be 0 because the current doesn't pass from there. Fine. Then it says when S1 is closed and that is open. Now because the resistance has decreased by 2 times and resistance is V upon I, if the resistance decreases, it's half now, so current will be doubled. So it means if this disconnects, so that means these are in series as well. So both of them, like X will have 2, reading on Y will be 2 and Z 0 because Z current doesn't pass, not connected. If you have any question, let me know. And then finally, both are closed. Then what happens is that now we got to find what happens to the current. Actually, this is so sad. Okay, let's do that. So the overall resistance is going to be reduced by 1 upon R plus 1 upon 2R. This is the total resistance I'm talking about. This will be 2R. This is 2. This is 1. So now the new resistance is going to be 3 by 2R. So this is going to be 2 over 3R. I don't know what 2 over 3 is. I think it's 1.67. Let me try. Yeah, 0.667. 0.6667. So we're going to say, if now resistance, now again, we're going to use the same ratio. If the resistance is now 2 by 3, so what will be the current? Current will be 3 by 2. Why do I know this? Because they're inversely proportional, right? So if the current initially was 1, right? So when it was connected, wait, that's not fair, right? There has to be something tricky in this. This can't be that simple, no? So 2 over 3R. If the current was like, when this was open, this was closed and that was open, the current was going as 2, right? Current was 2 here. So now the resistance is that at that time the resistance was R. So now it is 2 by 3 current will be this, and the current was this. So the new current will be 3 by 2 of I. So let me just 3 by 2 times 2. This is going to be 3. So you will have 3 here, and then it will be divided. How will it be divided? If you have 3, so in 2R you will get, so if you multiply R, it's going to get larger proportion of current because the total current is now 3. So this will get 2 and this will get 1. So why you will see 2? Because according to Kirchhoff law, right, the total current should be same. That's why. If you have any questions, do let me know. You can also, assume this. Like you can also take a reading of voltage. Like you can say, I'm going to take a voltage like 10 volts, 12 volts, whatever, right? And you can then also do that. So you can find resistance and do that. Yes. Any questions, please? Let me know.
Can you explain this again?
Can I do what?
Can you explain this again, the last part?
Okay, I'm going to explain it with a different method. Okay, I'm going to explain this with a different method. This will help you get it like the logic that I've used. Okay, so what I'm saying is, because it says initially when the reading was when S1 was open and S2 was closed, right? So reading was 1 here, and the reading was 1 here and 0. So I'm going to use this circuit to find the, let's say I have voltage, I've assumed this. So I'm going to use V is equal to IR, and the total resistance is like 2R, and the current was like 1, okay, a month, and that's basically 12. So the total is going to be, sorry, 2R. So total is going to be, R comes out to be 6 ohms. Do you agree? So this R is 6 ohms, this R is 12 ohms then, according to this resistance voltage that I've assumed. It doesn't really matter, the current will be the same still. So then what will happen is that now when one is open, when it's closed, so when this is closed and this is open, so we can use V is equal to IR again. Okay. So voltage is 12, the resistance is like 6. So what do I get? 2 ampere. So I'm going to use 2 here. And also Y, it will be 2 and 0 because it's not connected. Do you guys understand what I'm doing? Then what you're going to do is, when they're both connected together, now this is 6 ohm according to this value. Okay. So we're going to use V is equal to IR. According to the resistance, I'm going to find the total resistance. So the total resistance is going to be 1 upon 6 plus 1 upon 12. So you're going to do 12. This is going to be 2 plus 1. And 1 upon total resistance is going to be 3 over 12. And total resistance then will be 12 over 3, which is 4. Okay, so I'm going to use V is equal to IR, and to find the total current, I have to use total voltage. This is I, and this is like 4. So what you get? 12 divided by 4 is 3. So you get 3 as total current. Okay. Now, whatever the voltage is, the voltage will be applied here as 12 and also 12 here. So I'm going to use V is equal to IR. So the voltage will be 12. I want to find the current for 6. So it is going to be 2 ampere. And then V is equal to IR again. 12 voltage, current I want to find, and 12 ohms. So what do I get? 1 ampere, like that. Do you understand now? So you can use the ratios or you can use this. It's all right. This was a sort of, you just need to assume. You can use to assume any value. You can put 100 here, doesn't matter. You can put 200, 1000, doesn't matter. Usually, like, it's a tip for you guys to remember. Use 12, okay? Use 12 volts. Because in the question as well, you'll see the examiner uses the same amount of voltage every time. So your values will not be in points then. Usually they do that. So you can do this. It's alright. Then it says fluorine 18. Fluorine 18 is an isotope that decays into isotope oxygen by emission of beta particles. Complete the nuclear equation for the decay, including all the particles involved. So fluorine 18 is going into oxygen and isotope of oxygen and a beta particle, beta positive. So it's going positive. And obviously with anti-lepton, we gotta have a lepton release, which is anti-neutrino. Oh, sorry, normal neutrino. And then this is 0. This will be 18. This will be like, if you check the mass, this is going to be 18. Check the charge, it is going to be plus 9 equals 2 plus 1 and 0. So it has to be 8 then to be the same. Okay. Now, if you still have any issues, then when you write it, you have to write mass like 18 equals to x plus 0 plus 0. So that's why it is 18. And then you can find the charge where plus 9 equals to x plus 1 plus 0. So it's going to be 8. So you can do that as well if you're still confused about it. Anyway, so it says a quark in a fluorine 18 changes to flavor during this decay. State the change. Whenever this goes, like you have a positive decay, you need to understand that the proton has gone into a neutron. Yes. And when the proton into a neutron has been released, so then it has to be interesting. Wait, proton is up, up, down. It is up, down, down. So up changes to down. Okay, so it's up goes to down. Then a hadron has a charge minus 2e, and E is the elementary charge. State and explain whether the hadron is a meson or a baryon. So it says hadron has a charge minus 2e, where E is the elementary charge. Minus 2e. Oh, interesting. Now we need to check it if it's a hadron, is a baryon or not, right? So meson, the issue with meson is that mesons have either one quark and it's made of an anti-quark. So any situation like that, right? So if a quark is plus 2 by 3 and anti-quark is like plus 1 by 3, so you get 1e. So either it can be plus 1e or it can be like minus 2 by 3e or plus 1 by 3 or negative 1 by 3. So you negative 1e. Or it could be like minus 2 by 3 and plus 2 by 3. And that could be 0. So a meson can only have these three charges. Okay. So if it's plus 2e, it means that it must be a baryon. Okay, so I'm going to say to do this, the only way you got to do is that there has to be something like minus 2 by 3e plus minus 2 by 3e minus 2 by 3e. Okay, so this is going to be 6 minus 6 by 3e, which is minus 2e. So there must be 3 quarks, and that is a baryon. Baryon consists of 3 quarks. Remember this. And then it says state a possible composition of this hadron. So you need to put any 3 anti things. Okay. So if you remember, I told you that plus 2 by 3, you have up, top, charm. Okay. Negative 1 by 3, you have down, bottom, and strange. So we need 2 by 3 to get to this point. That means you could be, you can write anti up, anti top, and anti charm. Like if you have written, if somebody has written anti up, anti up, anti up, that is also correct. If somebody has written anti top, anti top, and anti charm, 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 that's also right. Or if you've written anti charm and top, that's also fine. So you have to have any 3 of these anti particles of these in any flavor. Okay, remember that. Any questions, please let me know. All right, then. So I guess we're done here. And pretty good then. All right. So now the last thing you're going to